Hello everyone. So today we'll be going to see TailMap method of TreeMap. Okay. So the TailMap method in Java provide a powerful way to work with the subset of a tree map where the keys are greater than or equal to a specified key. So it's an essential method for range-based operation on sorted maps, especially when data is ordered and needs partial access. So this is a signature of this method. It will return a sorted map. Then we have to pass here a key. Now, other than that, it has one more this parameter, that is which we want to pass here a boolean value, that is nothing but inclusive or exclusive. For that purpose we use this. So once we go ahead with the examples, then we'll get to understand this. Now if I keep here this example, here I will be using this tree map. Now in the map we are putting key value. Okay, the key is integer and the value is a string. Now what I want is, I want the elements which are greater than 2, which are equal or greater than and equal to 2. Now what I have done here is I have used this tailmap method on this tree map. Now I want the greater than or equal to element from the 2. So the elements, the keys in this map which have the value equal to 2 or greater, that entries I want. So here I have used this tail map and I have given the key because I want the entries which have the where the key values is greater than or equal to 2. Now if I try to run this, we can see 2B, 3C, 4D. Okay. Now suppose our requirement is we want the values entries where the key is greater than or equal to 3, then we can put here a 3. Now if we try to run this application, we should get this 3 and 4. Let's go to the another scenario where inclusive. Now what we have seen here is when we give here a 3, it will start it from 3, nothing but it is equal to, it will see for the key equal to 3 and greater than it. But if you want only greater than 3, if you don't want the key should be equal to 3, then there is another way we can do. So let me copy this, and if you go to here, I'll paste it here. So here what we can do is, now the requirement here is we want the values, the entries which is having the key greater than 20. So I don't want the entries that is equal to 20. I just want it should be greater than 20. So for that I have given here a false. Now if I try to run this as a Java application, see here we got the 30. Now what I will do is I'll delete this. So its return type would be sorted map. Now if I try to run this as a Java application, we can see we got inclusive, that means greater than or equal to 20. So if you want to exclude So whatever the value here we are giving, then we can use this method with the specifying this boolean value. Now if you want to like greater than equal to key, whatever the entries, if you want where key should be greater than or equal, then we can use this tail map and we can directly pass this key. It will give us a sorted map. But if you want that to exclude, okay, then what we can give is this. Here we have to give the boolean value as a false if you want to exclude from that key, nothing but the greater than the from key, and its return type would be navigable map. Now the same example here we have, let me copy this and let's check with the giving this boolean value as a true. Now if I try to give this and run this application, you can see it is inclusive. So it had included 20. Now if I give here a false, we would get only 30 equal to z. Now let's go to another scenario. Here is an example. So now here we have a tree map where the key is integer and value is a string. Now I want the entries which are greater than, where the value of that uh, key in that entries is greater than 2, greater than or equal to 2. So what we'll get here, we'll get 2 comma 3, 2 2 and 3 3. Okay, now again what we'll do, we'll modify this map. We'll put this key as a 4 and value as a 4. Later what we'll do, we'll remove this key 2 from the original map. Then the map will look like, the map will have the keys as 1 comma 3 comma 4. So this will reflect here as well in the tail map. As we don't have a 2 and one more entry is added, so the tail map will contain 3 comma 4. So once we run this application, you will get the idea. Now if I try to run this Java application, so first what happened, original tail map was, it was containing 2 comma 3. Why? Here we are using a, we have given a key as a 2, so whatever the entries which is containing key greater than or equal to 2, that will come into tail map, that is 2 and 3. Next we have modified this original map, we have kept 4 comma 4, then we have removed the 2, so the original map will become 1 3 4, as we have added the 4 and we have removed the 2. Now if we try to print the our previous tail map, the changes will be there as well, because the 2 was removed and 4 is added in our map. So if you can see that are reflecting here as well. Now while using this, if we give these non-existing key as well, then what will happen, the map will start from the next hierarchy. Now let's try to see this here. Now here is a tree map. We are putting key value pairs, and in the tail map we have passed the 20. Now the 20 is not present here. So what will happen is the map will start from the next hierarchy. So in this we have the next hierarchy as the 25. So it will print 25C. Now if I try to run as a Java application, see 25C is printed. So this is one scenario where this key was not existing. Now here is an example where the from key is greater than the largest key. So in that case the tail map will be empty. So we have here a tree map containing 10, 10, but the from key is greater than this element. So there will be no element like entries that is great which have the key greater than this from key. So it will print this empty. The next scenario is combining tail map can work alongside with the head map as well as sub map. Now here we have map which is having 5 entries 1 2 3 4 5. Now here we are having tail map and the key is 2. So this tail map will contain the entries having the key greater than or equal to 2. The head map will contain the keys which is smaller than 4, and the sub map it will be keys in the range 2 comma 4. Now if I try to run this application, see the tail map greater than equal to 2 2 3 4 5. Head map it will exclude 4, so till 1 2 3. Now in the sub map it will include 2 but exclude 4. This parenthesis you can see this is a square one, this is our normal. That means 2 will be inclusive, 4 is exclusive. So submap will be 2 comma 3. Let's check the another scenario where null pointer exception. Now from key here we have given as a null, then we'll get an exception. Null key is pass, a null pointer exception is thrown. Now if I try to copy this, so here we have tail map, we have given the null. Here we go, null pointer exception. The key we have passed is a null. So when we can use this method, when we want to retrieve all the elements greater than or equal to the threshold key. Other than this, like filter and work with the live subset of the map, efficiently stream the data starting from a specific key in a sorted order. So by combining it with the tree map method like head map, sub map, tail map, it enables flexible and precise manipulation of the sorted data. I'll give the link of this in the description so you can practice these basic scenarios for using this tail map method. So if you like this video, you can hit like button and subscribe to our channel.